All right, welcome AS Chemistry to part 2 of this video. And so where I left off on the last video is we were going over the energy, the light question, light equations, light questions, and this one specifically was asking for what is the energy of red light. And it gives us the wavelength, lambda, which is equal to 7.0 times 10 to the negative 7 meters, and it's asking us to find energy. And so the question mark is energy. Now, I always first start off with writing out my given and what I'm trying to find. And so this is our given, this is what I'm trying to find. And so then based on that, I try to figure out what equation to use. Now, here are the two equations you'll be given along with the information that you'll be given, right? You'll be told what each of these things mean, as well as the value of any constants like H and C. But you do have to be able to plug in. And so, once we've written down what we have and what we're trying to get to, then we can determine, okay, which one should I use, this one or this one? And so what we see is, well, we're given lambda, so we should probably use the second equation, right, which has lambda in it. But, you know, if you do that, you'll say, okay, well, that's good, I could plug into lambda, but, well, I'm trying to find energy, right? So I really probably want to use this equation. But we're not given that, we're given this, and so you're like, wait, what, how do I do this? And I ended off last video by telling you the key is this guy, F, frequency. If you can solve for frequency here, given the information C and lambda here, then you can just plug it in to here. And so then you can plug it into this equation, and then you're given H, then you can solve for E. Right, so this is how we're gonna go about attacking this. And so we're gonna first say, okay, well, C is equal to lambda F. Lambda therefore, lambda. F therefore is going to be, end of day. I've used up all my brain cells at this point. Lambda, if we divide by lambda on both sides, we can get just F by itself, right? So lambda is going to cancel. C divided by lambda is going to be equal to F. And so if you get F, then you can plug into E is equal to HF, right? You can take this and plug it into here, and then you can solve for E, right? And so let's do that. C, it says here, is 3.0 times 10 to the 8 meters per second. I'm going to put that in parentheses. I'm always going to put any number in scientific notation in parentheses so that it makes it so that when I plug it into my calculator, it makes sense and I can do it easily. And so, and correctly. And so 3.0 times 10 to the 8 meters per second divided by lambda, which we said is 7.0 times 10 to the negative 7 meters. Put that in parentheses. Then the meters are going to cancel each other, and we're going to be left with over seconds, and we'll see what that means in a second. So this is equal to F, right? These guys are equal to F. And so 3.0 times 10 to the 8, let's put that in our calculator. All right, so 3.0 times 10 to the 8, right? All that in parentheses. Divide by 7.0 times 10 to the negative 7. All that in parentheses, put it in. 4.2 E14, that means times 10 to the 14. I guess it's 4.3. Yeah, actually, no, I have 3 sig figs here, right? So I should have 3 sig figs at the end. So 4.28, 4.29. 4.29 times 10 to the 14. What's my unit? Well, it's over S. So it's over S, right? All that is equal to frequency. Now, we normally put a 1 here as a placeholder, so it's 4.29 times 10 to the 14, 1 over S's, or also known as hertz. Okay, so 1 over S is also known as hertz. And so that's frequency, but I guess I shouldn't really box it. I should just kind of circle it. Because really, yeah, what we're going to do is we're going to then put it into E is equal to HF. And maybe, let me put that here. So E is equal to 6.626 times 10 to the negative 34 joules per second, because that's what H is. You might be saying, how do I know that? Well, it's given here, right? And you'll be given that, so no need to memorize. And then F, we just found, is 4.29 times 10 to the 14, 1 over S is S times 1 divided by S is going to just cancel each other, so we'll be left with joules, which is the unit of energy. Energy, therefore, is going to be equal to, you don't have to put these ones in parentheses, to be honest, because all we're doing is multiplying, not dividing, so unit or order of operations doesn't matter, but just for consistency's sake, so that you guys get in the habit, I'm going to put parentheses around all of my numbers in scientific notation. And so this is what we get. 2.84 times 10 to the negative 19. 2.84, 3 sig figs, right, times 10 to the negative 19 joules. And so that's my final answer. Cool. So yeah, that's how you do that problem. And so a little bit complex, right? We need to utilize both equations, but nothing you can't do. And remember, again, the key is F. F holds the key to doing this problem. So cool. Okay. So I'm not going to do this one. This is just blue light. And so it's the same thing. One thing you'll notice is that the energy of blue light is greater than the energy of red light, right? And that makes sense, right? Because blue light has higher frequency and therefore higher energy, right? Remember, blue light, I guess if I want to use colors, right? Blue light will be something like this versus red light is like this, right? And so it makes sense that blue light has higher energy because it has higher frequency, right? And so, yeah, you'll see that, but I'm not going to do it in this video because the same thing as red light. Cool, okay. What is the speed of red light? Remember, speed of any light is always the same. Speed is going to be 3.0 times 10 to the 8 meters per second. The speed of blue light is also going to be 3.0 times 10 to the 8 meters per second. You don't have to calculate it, right? But you just show it. Cool. Okay. And then let's go to this one. A photon has a frequency f of 2.68 times 10, and that should be 10 to the 6th. Okay, 10 to the 6th hertz. Calculate its energy. And so how we do that is, again, we just take a look. We're like, okay, well, actually first I say F is equal to 2.68 times 10 to the 6th hertz. What I'm trying to get is energy. And so I'm like, okay, which one should I use? This one or this one? Well, let's see. I'm given this, and I'm trying to solve this, so there's no reason to use that, right? I'm going to use E is equal to HF. E is therefore equal to 6.626 times 10 to the negative 34 joule seconds. Frequency is that. I'm going to use 1 over seconds here so that I can see these cancel. And therefore energy is going to be equal to 6.626 times 10 to the negative 34 times, times 2.68 10 to the 6th. You're going to get 1.78 3 sig figs, because we started off with 3 sig figs, times 10 to the negative 27 joules. And there you go. Cool. So that's how you do that problem. And so that hopefully is, that's the last one. And so hopefully all of that helped you prepare for your celebration of learning. You guys are going to kill it. Please do this. Please also make your little study guide. And I'll collect those from you guys. And yeah, you guys are going to do great. Can't wait to see it. So proud of you guys. You guys are going to do so well. Let me know if you have any questions. Feel free to come by tutorial on Friday. I can help you guys out. But you guys got it.